In today's lesson, we are going to solve this ordinary differential equation. Let's dive in. dv over dt is equal to, we can distribute the negative. This will be negative alpha v, negative beta t. Now, the way to go about this, we must arrange it into this form: dy dx plus p x y or equal to qx. The function that we need to have after the equal sign must be a function of x alone. It must be a function of the baby function, of which here the baby function is t. Here, which will be adding to dy dx, which is in this case dv dt, we have to have a function which has the main function in it, dy plus y. It can multiply with a function of x, it's okay. It can multiply with a constant, it's still okay. In this case, in this question, we were told that alpha and beta are what? Are constants. So from here we can see that dv v. So this has to go this side. It could have been positive here. We should have taken it the other side and it was going to be minus. It's still okay. It doesn't have to always be positive here. It doesn't have to always be positive here. It can be negative, negative. It's still okay. So we'll add this both sides so that it goes to the right, to the left side. So dv over dt plus alpha v or equal to negative beta t. Now from here, how we are going to do it is we need to solve this as a function of v, as the question has said, and that is what must be done. So the first thing for our solution, we have to solve this for the function of v. This is our solution. Now v must be multiplied with an integrating factor. So how do we find the integrating factor? We go back to the fundamentals. The integrating factor, which I will denote as ux, must be the function of exponent. We are going to integrate whatever px is. We're going to integrate whatever px is with respect to dx. This is going to be our integrating factor. So we're going to multiply our main function with the integrating factor, and we're going to equate it to the integral of the integrating factor multiplied by qx. This is how we're going to find our solution using this. And viewers, we are making free videos, and for you to help us find an audience, you can just hit that bell icon and subscribe to our channels. Let's continue. Now we have to identify what ux is. For us to find ux, we just need to find what px is. Now what is px? According to this, we can come and see here. Px, it is alpha. So we are going to write it as exponent, the integral of alpha with respect to x. So this is the same as the integral of 1 with respect to x. So our integrating factor, it will be the exponent of alpha multiplied with x. So we are going to multiply this with our main function, and we are going to multiply this with the qx and integrate them. So this is our next step: v multiplied by the integrating factor, all being equated to the integral of the integrating factor and our qx, which is negative beta t. t. Now, since this being a constant, we can factor it out. It being a constant, we can factor it out together with the negative. So what we are going to have is v, integrating factor, equal to, we factor out the constant because it behaves how numbers behave. It's a constant. So what we are integrating is this. Now, if you look at our function which we have here, it's a function of two functions multiplying. So it's a product. So how do we integrate two functions which are multiplying? We're going to use the by parts method. So for by parts method, we have to identify our u and our dv. How do we identify? We are going to use a very simple technique, which is LIATE, which I like calling as liate. The first letter, it stands for log. The second stands for inverse. The third is algebra. The fourth is trig. Then the fifth is exponent. Now we just have to ask ourselves a question. Exponent of alpha to the power x falls in which family here? We can see that it falls on in the fifth family for the exponent itself, which is this. Now t falls in which family? The algebra family, which is here. Now for us to identify which one is u is the one which is going to appear first in our little trig, our little sequence. So from the look of things, we can see that t is appearing first than the exponent of alpha multiplied by x. And let me classify on one thing. Look at our baby function. Our baby function is dt instead of dx. So we're integrating to find our main function with respect to t. So this is, instead of it being x, it's going to be t. Let's just make that correction. This is going to be t as well. It's the same thing here. It's going to be t. It's going to be t. It's going to be t. Now, what is our u? Our u is t. Our u, it is equal to t. Now, our dv, it is equal to the exponent of alpha multiplied by t. Exponent of alpha multiplied by t. Now, we have to know how the parts method works. By parts says that u multiplied by dv. For us to integrate this, we have to multiply v with u minus the integral of v du. So we have to find two things which we are seeing here. We have u and dv, but we need to find v and du. How do we find du? We just need to integrate u, to differentiate u. How do we find v? We just have to integrate dv. So du will equal to, when we differentiate t, we're just going to get dt. For us to find v, we have to integrate dv. So v is equal to, now how do you integrate exponent? How do you integrate exponent? So exponent, let me give you this quick example. I'll say exponent p. If we are required to integrate exponent, we are going to repeat it the way it is, then we are going to divide by the derivative of the power. So in this case, when we were given exponent 2x, we're going to write it the way it was. Then what is the derivative of 2x? Derivative of 2x is 2, so we're going to divide by 2. That's the same thing we're going to use here. So we're going to write it the way it is, then divide it by the derivative. When we differentiate that with respect to t, we're going to get alpha. So this is our v, this is our du, this is our dv, this is our t. So what is our v? Our v, it is exponent alpha t over alpha. What is our u? Our u is t. All that we subtract it with our v, which is the same, then our du. Our du it is dt. Now from here we can see that this we can integrate. We can just factor out the constant, which is 1 over alpha, and then integrate that. So this will all turn out to be exponent alpha to the power t over alpha multiplied by t of that 1 over alpha, then the integral of exponent alpha t dt. So when we integrate this with respect to t, we're going to follow the same order we did when we are integrating that. So this will turn out to be, at last, it's going to turn out to be this 1 over alpha. This is the same as this bad boy. This is the same as this. Yes. So now from here, we are not done. Remember, our solution has to be in that form. And what were we finding? We were just finding this part. And remember, we were also given what? Conditions, which will help us to find the integrating factor. Now from there, let's go ahead and add our integrating factor, which is a plus c. Then from there, we can multiply the whole function, because this function, remember, we factored out a negative beta. So we have to multiply this with this. Then after that, we are going to add the integrating factor, which is a constant plus c. So what are we having? As our final equation, which we are going to equate to v exponent alpha t. After multiplying by negative beta, this is how our final equation turns out to be. So we have to equate this to v exponent alpha t. V exponent alpha t. So this is being equated to v exponent alpha t. Then we're going to replicate, we're going to write the right side the way it is. We're going to write the right side the way it is. So we were given conditions which said that when v is equals to u and t is equals to 0, the conditions are given in the sense that it helps us to find what? To find the constant of integration. So we're going to substitute where there is v, we're going to put u. Where there is t, we're going to substitute with, wherever we're seeing t, we're going to substitute with a 0. So here, let's start. This will be u multiplied by exponent to the power alpha multiplied by 0. So it's the same as exponent to the power 0, which is going to give me a 1. This is going to give me a 1 equal to, I can see that there's a t multiplying everything, so this is just going to turn out to be 0, plus beta alpha squared. When I put 0 for t, it's going to be exponent to the power 0, which is 1. This is plus c. Now for me to find c, I just have to subtract this both sides. So I'm going to have c is equal to u minus beta over alpha squared. So from here, I'm going to go and replace this where there is c. I'm going to replace it where there is c. I'm going to replace it where there is c. I'm going to write everything the way it is. Since now we have found our integrating factor, we just have to replace it where there is c. Where there is c, that's where we just need to. So where there is c, I'm going to put u minus beta over alpha squared, like this. Here, where we have reached, you can leave it as your final answer. It's still okay. Where we have reached, it can be the final answer. But you can try to simplify. Since they have said we need to write the answer in terms of v. Look at this. This term as exponent alpha multiplied by t, the same for this. So we can factor out this. We can factor it. Let's go ahead and factor it out. So let's write the left side the way it is. and factor this out. So this is going to be this boy negative beta over alpha multiplied by t plus beta over alpha squared plus this alpha squared. Now from here we can just divide exponent alpha to the power t, which is just the same as which when we divide it will be just the same as negative exponent to the power negative alpha multiplied by t. So this is the same as v equal to, when we divide it will go here, this will cancel, so we're going to have negative b over alpha t plus b over alpha squared, then plus. Now for this one, since this term we are dividing by this term, we are dividing here by the same exponent, here by the same exponent. Here there's no exponent for it to cancel. So for this part alone is going to be alpha minus beta over alpha squared to the power exponent that multiplied by exponent to the power negative alpha t. This is the same as over. When the concept we use is 1 over a is the same as a to the power negative 1. So 1 over exponent alpha to the power t is the same as exponent to the power negative alpha t. So this is our final answer, ladies and gentlemen. Thank you for watching.